All right, guys, welcome back. So Mr. Moscato with you again. All right, so in the last video, we took a look at points. All right, how to identify a point on a coordinate grid, right, using its x and its y value to describe the point as x comma y. All right, so for this video, then, what we're going to do is we're going to take a look at equations that describe a line, right? So these are called linear equations. All right, and we're going to take a look at the standard form of a linear equation. In other words, what does an equation look like, all right, when it is described as being in standard form and that equation describes a line. All right, so let me go ahead and switch over screens here and just give me one sec. All right, guys, so here we are. We're on page 155 in the book. You probably want to follow along. All right, so what is the standard form of a linear equation? Well, the standard form of a linear equation is described as an equation that is written as a times x plus b times y, right, equals c. So some value times x plus some value times y equals some constant value c. All right. So a is a value, b is a value, c is a value, and then depending on what x is, y is going to change, right? So x is our input and y is our output. If an equation can be written this way, then it is a linear equation. Okay. The equation describes a line. All right. So let's take a look at the example one over on page 155. All right, so they give us an equation, right? Y equals 4 minus 3x, and what they want to know is is this equation a linear equation? Does this equation describe a line? Well, there's a couple of different ways that we can do this. We can write this out, okay, and we can plot every point, right? We can start picking x values. We can start figuring out y's, and then draw the graph and see, does this equation actually give us a line? Or we can try to write the equation in standard form: a times x plus b times y equals c. If we can do that, then we have a linear equation. All right. So the whole idea behind standard form is that we want the x values and the y values over on the left-hand side, right? So in other words, we want something times x plus something times y equals something else. All right? So all of the regular algebra rules apply here, right? Everything that we've been doing up to this point applies, right? I'm trying to get things from one side of the equal sign to the other side of the equal sign. If I do something on the left-hand side, I have to do it to the right-hand side. If I do something to the right-hand side, I have to do it on the left-hand side. All right, I want to try to get this x, right, this 3x, over to where the y is. Okay, well, I can do that, right? If I have a negative 3x on one side and I want to move it over to the other side of the equation, right, well, I'm going to add 3x over here, and if I do so on the right, then I have to do so on the left. I'm going to add 3x over here. So what does that give me, right? So over on the left-hand side, I have a positive 3x combined with a y, all right, gives me 3x plus y, okay, equals, well, the negative 3x and the positive 3x cancel out, so I'm left with a 4 over here, right? So do I have a linear equation? I have something times x, right? I have a y, and then I have a constant, all right? I do have a linear equation because right, so I have value for A is 3, the value for C is 4. Do I have a value for B? Yes, I do, right? Remember that when a variable stands by itself, we can assume that it is being multiplied by 1, right? So I can rewrite this as 3 times x plus 1 times y equals 4. Okay, where A equals 3, right? B equals 1, and C equals 4. This describes a linear equation. Okay, something times x plus something times y equals 4. Okay, now In example B then, all right, down here, they have another equation, okay? And they're saying that 6x minus x times y equals 4. Does this describe a linear equation? Well, in this case, it doesn't, right? Because it is not in the form of some value times x times some value times y. X is an unknown value, right? It's a variable, right? No matter what I do to this equation, I will not be able to get it into standard form. A times x plus b times y equals c. All right, and if you don't believe me, go ahead and try, right? Try to get the x's together. Try to get, some constant value times x minus some constant value times y equals some other constant value 4, right? Can't do it, right? So this equation does not describe a linear equation. It describes some other kind of equation, all right, just not a linear equation, all right? So hopefully that makes sense. If not, right, what you can do is plot some points, right? Pick a value for x, figure out what y is, put them on the coordinate graph, and see what shape it gives you, right? There's also some function calculators online. You can you can put this equation in to that function calculator, and it will draw the graph for you, okay? And see what it gives you, right? So that's, that's another way to double check that, all right? So the last thing I want you guys to do here for this lesson is I want you guys to do guided practice 1A and 1B. So in other words, tell me, all right, does 1/3 y equal -1? Is that a linear equation? Does that describe a linear equation? And then when you're done with that one, go ahead and try 1B, right? Y equals x squared minus 4. Does that describe a linear equation, right? So I want you guys to pause the video and do those two problems. And then when you're done, start the video up again and we'll talk about it. Okay, good. So pause the video here, do those two problems, and then we'll keep going. All right, so hopefully you tried those two problems, right? So 1A, right, is 1/3 y equals -1, right? Does this describe a linear equation? All right, can we get it into the form of ax, right, plus by equals c? All right, so what do you guys think? Yes or no? Show of hands. Awesome. Okay. This is a linear equation. Believe it or not, this is a linear equation. And you're maybe saying to yourself, well, what about the x? There's no x there. Well, there actually is an x, okay? Or we can make an x, all right, by having a equal to 0. So I can rewrite this equation as 0 times x, right, plus 1/3 times y, right, or y over 1 or over 3, right, equals -1. Okay, so 0 would be my a value, 1/3 would be my b value, and -1 would be my c value. Okay, we're going to come back and draw this graph out, but for right now, just understand that this is a linear equation. When we draw this out, all right, no matter what value we put in for x, we're going to get a y value of basically -3. All right, so we'll go ahead and draw that this graph when we actually start drawing equations in the next video. Right, drawing the graphs in the next video. All right. What about 1b? So this is a linear, okay, equation. Let's put that down. All right, good. What about 1b? Well, 1b is y equals x squared minus 4. Y equals x squared minus 4. Is this a linear equation? And the answer here is no. All right, so I could, subtract x squared from this side and subtract x squared from this side. all right, and come up with the value or the equation negative x squared plus y equals -4, all right, but this is not a linear equation because I have an exponent on the x, all right? I'm multiplying x by itself. This is not a linear equation, okay? This is a quadratic equation. This is an equation that is going to give us a parabola. We're going to take a look at those later on down the course, okay? But just understand that um, the focus of a linear equation is that we have x, right, to the first power, right, no exponent, y to the first power, right, no exponent, multiplied by x times something and then y times something else, all right, or you know, it could be the same thing, but some value times x plus some value times y equals some other value, all right. This is not a linear equation, okay? So hopefully that clears things up for you a little bit. Okay, if you don't quite get it right, go back over the review stuff there on page 155. Then the next thing that I want you guys to do is to go ahead and read page 156 and 157 just to get an idea of what the x and the y intercepts are. All right, so the next thing I want you to do is read page 156 and 157. All right, go over those things, make sure that you understand the concept of an x-intercept and a y-intercept. And then in the next video, we're going to use the standard form of an equation to actually draw the graph. Okay, so yeah, we'll see you guys in the next video.